Chalo, check. Alright people, I believe we are live. Welcome to Catalysis by Vedantu. My name is Pahul, and if I'm audible and visible, please write yo in the chat box. You know the drill. Apparently people did not get the notifications, and I think that is because we made a few live events at the same time. So for example, tomorrow's live event was created, today's live event was created. So I think one notification went and one did not. Something like that happened. YouTube, you know, is weird. Yeah. So let's see. I can see in the chat box lots of people did not get the notification. Anyway, let's talk for 2-3 minutes so that now that the live session is on, maybe some people will get the notification that, you know, Catalysis is live. So theek hai. Anyway, if everything is good, please write you in the chat box. Now people, today we are here to discuss the chapter of alkyl halides, and this is one of my favorite chapters from organic chemistry. In fact, the entire syllabus of organic is my favorite. But this chapter is interesting because even though you are taught lots of things in this chapter, the entire chapter, the questions that come from it, revolve around just a few things. Okay? They revolve just around a few things. For example, SN1, SN2, E1, E2, anti-addition on the double bond, free radical halogenation, etc. Those are the main things that, you know, are asked in the examinations from this chapter. Otherwise, nothing more. Achyut, don't worry, I'll call you Achyut from today. ठीक है जी, बढ़िया. तुषार सिंह सर नेट नहीं चल रहा इन हरियाणा, क्या करें भाई. Cool people. So we have 70 viewers right now. Let me switch to the first question. धीरे धीरे अपन बढ़ा लेंगे आगे चीजें. Yeah. Shruti, that is Diggy, D-I-G-G-Y, and it's by an artist called Patrick. I took it from the YouTube's free music library. Yeah. So it's free music. You can use it in your videos as well. Anyway, people, let's do this question first. Okay, so whatever questions I've kept today are very relevant for your exam. There are 1 or 2 googly questions that I've kept towards the end, okay, which are really tricky, but most of the questions that I've taken are of a decent level. These are absolutely relevant for your examinations. Let's do this question first, okay. So what's going on over here? This is the initial substrate you have. You are going to react it with HBr in the presence of heat. After that, you are going to put sodium and ether in it. Okay, so 2 reactions, both from the chapter of alkyl halides, very interesting. Okay, yeah, a lot of people will just now get the notification that we are live. So people who are joining just now, don't worry, this is the very first question that we are doing. Okay, RNSing, when will you take classes of advanced level? Once the JEE first attempt is over, then I'll switch to advanced level classes as well. Okay, fine. Funny, yeah, I'll do that, man. Funny Meghna, I'll do that. What's your surname though? Funny is your surname or Meghna is your surname? Sorry for that noob question, but I would like to ask you that today because you are in the classes every day. That's nice. Hannah John is saying, I'm new to your channel. May I know the schedule? These days we are doing live sessions of Hybrid Sprint at 8:30 from Monday to Friday. Yeah? Chalo. Almost 100 viewers now. Let's do this question. क्या करेंगे दोस्तों? What do you think is happening in this question? अरे यार. Yeah. What do you think is going on in this question? What is the first step? Yeah. HBr in the presence of a little bit of heat. And as you can see in the options, okay, what are the choices for A? Either this or this or this or this. Essentially what is happening is HBr is breaking apart the epoxy linkage. Yeah. HBr is breaking apart this ether linkage. Yeah, that's what we have to do. Either bromine will come here or oxygen will come here. Hai na? So basically there are 2 alternatives that you have to choose from. These 2 are the same, these 2 are the same. You have to choose from these 2 alternatives. Okay, I mean A will be either of these 2 structures. Fine, do you understand? So we need to judge which of these 2 structures can be your structure number A. Okay? That's the first judgment that we need to make. After that, we need to do a very interesting reaction with sodium and ether, and I'm pretty sure you guys realize what that reaction is. Yeah, okay, cool. So what do you think is the answer? What do you think is the answer? I'll do the entire reaction for you, don't worry, but what do you think is the answer first of all? Samarth and Anish and Ragashri are saying option number 3 should be the answer. Okay, we'll check that. Obviously, option 3. Ujjwal is also saying the same. Cool. So the thing is, lots of people are saying option 3 should be the answer. Let's try to figure it out step by step so that everyone is clear with it, if there are some people who are not. Fine. So this is what's going on. Yeah, you've got this type of a system over here, and yahan pe you have your bromine. Now when we add HBr, what's going to happen is essentially this oxygen will get protonated. You have H positive with Br negative, so oxygen can get protonated. Yeah, once it gets protonated, it becomes a good leaving group. Yeah, this has a positive charge right now. Now the decision that we have to make, which is very obvious, is whether bromine will attack here is whether bromine negative, yeah, will attack on this carbon or on this carbon. These are the two choices. Obviously, bromine can't attack on the carbon that belongs to benzene. Doesn't work, right? Phenyl substitutions are very bad. So this won't happen. Only that part will happen. So what you will get after this reaction is a very obvious species. You essentially have a phenol derivative. Yeah. यहाँ पे आपके पास OH लगा मिल जाएगा. You have this jazz over here. How many carbons do we have? 1, 2, 3 more carbons on the top. And then you've got another bromine that has just attached itself to this carbon. Yeah, 1, 2, 3, 4, 5. Cool. This is what's going on. Now, my dear friends, अच्छा यहाँ पे bromine है. Sorry, I forgot to draw that. Yeah, this is what's going on. Now the next reaction was sodium in ether. Can you name this reaction? A very common reaction that comes every year in some place or the other. Can you name this reaction, please? Yeah. Bhavya is asking, sir, when will you start the GOC model? Because Bhavya, I'm actually, talking to my team. Yesterday also I had a discussion. We are trying to plan something big around that course. So as soon as the logistics are worked out, I'll let you guys know. It'll take a little bit of time, but yeah, I'll try to do that as soon as possible. Okay. Woods reaction. Yes. Woods coupling reaction. Japneet, Murlidhar, and Shruti and Vishnu, Karthik AW kya hai bhaiya? Yeah, okay, lots of people are giving me the correct answer. This is basically the Woods coupling reaction. Yeah, very common reaction to couple your alkyl halides together. Now the thing is that this Woods coupling reaction 90% of the times is a self-coupling reaction. For example, if you take this particular species, put it in sodium and ether mein you heat it a little, what will happen is this will couple with its own self. Something like this will happen. Okay, something like that is going to happen. Self-coupling is more favored. Cross-coupling is generally not gonna happen with Woods reaction. Cross coupling bole to, if you have this guy which you want to couple with, let's say this guy, okay, this attaching here, it's a difficult process. This attaching with its own self is fine. This attaching with its own self is fine. These two attaching with each other, it's a little difficult. And if you do Woods coupling reaction with these two substrates, you will get multiple products. Yeah, self coupling, cross coupling. So you will get multiple products in Woods coupling, and therefore you would like to do self coupling. But over here, the coupling that you have is intramolecular. Yeah, it's happening inside the same molecule. So the Woods coupling reaction essentially goes via a free radical mechanism. Okay, you'll get free radicals created on these carbons, and all you have to do is just join them. Yeah, and if you improve this structure, you'll realize it's just a 6-membered ring. Fine. So that, I believe, gives us option number 3 as the correct answer, which most of you were telling me already. So good job. Yeah. Nice. Let's move on to the next question. Can you read this carefully? Can you read this properly? If you can't read it, then I will do something. Okay, I think everything is clear. This part is a little blurred, I know. So what it is saying is, okay, यहाँ पे है KS. KS is for substitution reaction. This is KE. KE is for elimination reaction. ठीक है. So what is happening over here is, what's going on over here is, you have this substrate CH3 CH2 CH2 Br, 1 carbon, 2 carbons, 3 carbons and a bromine, and you are reacting it with Z. This is the nucleophile. Now this nucleophile could be either of these two. Okay, it could be very simple ethoxide ion, okay, or it could be this tert butoxide ion, है ना, ठीक है. These are the two options that you have. So you are either reacting it with a very simple ethoxide ion, or I'll draw the other option with the red color. You are reacting it with this very bulky nucleophile. Yeah, this is a simple small nucleophile, this is a bulky nucleophile. My dear friends, since this is bulky in nature, yeah, can I say that this favors elimination? Do you remember? Bulky bases always favor elimination because they're so huge, they don't want to go inside and react with the structure because there's a lot of steric hindrance. Capturing a proton is easy. Proton is a very small species, yeah. फटाफट से कैप्चर हो भी जाता है. Acid base reactions are very fast. So instead of acting as a nucleophile going all the way, since it is bulky, it just wants to sit in one place and do the quick reaction. So it favors elimination. Elimination goes via the capturing of a proton, yeah. Fine. On the other hand, for this guy, it doesn't favor a certain reaction. This particular substance can do substitution, can do elimination as well. Substitution or elimination, both are possible. Okay, this is a very good base and a good nucleophile also at the same time. So depending on the temperature, okay, if you give it a high temperature, it will undergo elimination. If you give it a low temperature, it will undergo substitution. Both reactions are possible because this is a very simple nucleophile. Okay, fine. So this one is case A and this one is case B. You essentially at the end have to compare mu B versus mu A and Ke versus, K of B versus K of A for elimination. Okay, substitution के बारे में कुछ नहीं बोला है यहाँ पे. Elimination. So what this statement says is Ks and Ke are respectively the rate constants for substitution and elimination. Okay, and mu is equal to Ks by Ke. What are the correct options? Fine. ठीक है. So substitution and elimination are competing. Ks is the rate constant for substitution. Ke is the rate constant for elimination. So if your reaction is faster, its rate constant will be higher. है ना? अब in these two cases, okay, these are the two cases. For case A, can I say that Ks is approximately equal to Ke? So for case A, I can say mu, which is equal to Ks upon Ke, is approximately equal to, let's say, 1. बोल सकता हूँ मैं. Yeah. Depends on the condition. If heat is high, E is more. If heat is less, substitution is more. Great. Now talking about option B, ये वाला. Since it is bulky, definitely its rate of substitution is going to be much lesser compared to rate of elimination. है ना? So over here mu, which is Ks upon Ke, definitely is going to be much lesser compared to 1. Yeah. 1 से छोटा होने वाला है. Do you understand? Because Ks is a very small quantity compared to Ke. So this is a very small number. Let us assume 0.1. Yeah. Just helps us do some calculations easier. Let us assume 0.1 हो गया. ठीक है. तो from here one very simple inference that I can draw is that mu A is greater than mu B. Which options have mu A greater than mu B? स्क्रीन से बाहर चला गया? नहीं भाई, स्क्रीन के अंदर ही है सब. I can see the view that you are having over here. Can you please, if you're watching on your mobile phone with a zoomed out view, just zoom it in, okay? I mean, with a zoomed in view, just zoomed out. Okay, बाहर कुछ नहीं गया दोस्त. ठीक है? So can I say this? Mu A is greater than mu B, is that fine? तो ये दोनों options eliminate हो गए. We are left with option 3 and option 4. Yeah. Now we have to figure out the differences between elimination constants. Of course, the rate of elimination for the bulky group is higher than the rate of elimination for the first case. Okay. So K of elimination for B will be greater than K of elimination for A. Yeah. Because this is a bulky group. For that, substitution elimination, similar rates. Over here, only elimination is going to be favored. So the final answer should be option number 3. Okay. Of course, exact values should be taken from the experiment. Okay. It is possible that this guy's elimination is also faster than this guy. Okay. This guy is doing only elimination. It doesn't mean it's doing elimination faster than the first case, but more likely the elimination over here will be faster. Okay. So this is the most likely correct answer. Exact answer should be done in the laboratory. है हो सकता है ना, ये कर रहा सिर्फ एलिमिनेशन है, पर हो सकता है एलिमिनेशन स्लो कर रहा हो, ये दोनों चीजें कर रहा हो सकता है दोनों फास्ट कर रहा हो. Understood? So exact answer should be seen from the experiment in the laboratory, most likely because ये सिर्फ elimination कर रहा है. Since this is doing only elimination, the rate for elimination over here will be a little faster. Yeah, considering it is a stronger base as well. Fine. Okay. Saurabh, yeah, I'll do that very soon, bro. Don't worry. Before we end the entire series of hybrid sprint, I will take that class. Don't worry. But that was a nice question. Simple, yet if it comes in your examination, there is so much to read. For 2 minutes, you'll be like, okay, what's going on? Yeah, that this type of a reaction does that to you in the examination. Now, let's look at this one. 1-methyl ethylene oxide, when treated with an excess of HBr, produces. What on earth is 1-methyl ethylene oxide? People, I have seen this, okay, in the previous 2-3 years. Listen to me carefully. In the previous 2-3 years, NEET and JEE have been using this term quite a lot. Ethylene oxide. Okay. Ethylene oxide is a common name. If you don't know what it is, you might be, drawing structures like this. ऐसा कुछ बनाने बैठ जाओगे? No, don't do that. Ethylene oxide basically is the fancy name of this guy. ठीक है? The cyclic ether is known as ethylene oxide. Now we have 1-methyl ethylene oxide. Okay, so please remember this is ethylene oxide. Don't forget that. 1-methyl ethylene oxide means that there is a substitution on one of the carbons. So this is your 1-methyl ethylene oxide. So this, when treated with excess of HBr, what does it produce? Dushyant, there are like 6-7 more classes remaining, I think. Okay, so now you have to react with excess of HBr. So you have to do multiple reactions with HBr if possible. HBr क्या है? Acid है. We've just seen what happens when there is, an ether in the presence of HBr. The very first reaction was ether in the presence of HBr. So the first thing that you would do in order to make this reaction a little simple is make oxygen a better leaving group. ठीक है जी. तो अब Br negative इस पे अटैक करेगा. Where will Br negative attack? Interesting. सोचो कहाँ रिएक्ट करेगा. No matter what you do, it doesn't, you shouldn't be worried about it. Okay, no matter what you do, you shouldn't be worried about it. It's fine. See, this particular case is essentially the acid catalyzed opening of epoxide. Yeah. Yeah, this is the acid catalyzed opening of epoxide. There is a positive charge over here on the oxygen. Now, in the acid catalyzed opening of epoxides, what you should visualize, okay, this is not what happens in the reaction mechanism. The reaction mechanism is a little fast. What you have to imagine, आपको ये चीज imagine करनी है अगर आपको आंसर सही चाहिए तो. Imagine this, okay? In the case of acid catalyzed opening, imagine the carbocation that can come out of this. What are the two carbocations that can come out of this? Just imagine, okay? एक तो ये बन सकता है, Yeah, if oxygen takes away from here, if this bond is broken, positive charge will be created over there. Otherwise, you can get something like this. Yeah, if oxygen breaks away from here, if this part of oxygen is broken, you will get this particular carbocation. Out of these two, which one is the more stable carbocation? This information for the question is irrelevant. I am repeating, this information for this question is irrelevant, but still I am explaining this to you in case they give you only one equivalent of HBr. That would have been a difficult question. Two equivalents of HBr or excess of HBr makes it an easy question. If only one equivalent was given, then what do you have to do? Since this is the acid catalyzed opening, in the acid catalyzed opening, you have to think of these carbocations, okay? And obviously you see that this one is the most stable carbocation. This one is the most stable, this one is the less stable carbocation. Why? Because this has more alpha hydrogens. Okay, this has more alpha hydrogens, 1, 2, 3, 4, 5 alpha hydrogens versus a very small 1 alpha hydrogen. Yeah. So you have to think as if the reaction is happening from this guy. Okay. So in the acid catalyzed ether opening, okay, more stable carbocation side, okay, more stable carbocation side is favored. Okay, please remember this idea that when you do acid catalyzed opening of these ethers, cyclic ethers, you have to choose the more stable carbocation side, which is usually the more hindered side. Is usually the more substituted side. Okay? So Br negative over here, if it comes, it will attack on this particular carbon. Okay, because this is the acid catalyzed opening. In base catalyzed opening, things are opposite. If you have base catalyzed opening of epoxides, that will happen from the less hindered side. Okay, so if you have, let's say, this type of an ether which is reacting simply with OH negative, okay, you put some KOH, let's say. So this OH negative is going to attack on the less hindered carbon. Please remember this. Okay, this is good for your JEE advanced level preparation. Fine. चलो जी, तो यहाँ पे इसका अटैक करेंगे तो the first attack will give me this sort of a product. एक second. Trying to maintain the color coding. And your bromine will get associated over here. And this is the first thing that you will get. This is the first thing that you will get. Now the second step is, I think, very simple. If you reacted with even more HBr, yeah, what's going to happen is OH will leave because it will become a good leaving group. So you will get something like this, yeah, carbocation, and this carbocation will get associated with bromine, ultimately giving you this as your product, which I think is the last option. है ना, कुछ गलत तो नहीं किया मैंने. हाँ, यहाँ पे एक कार्बन एक्स्ट्रा है. Yes. Is it in the screen? Almost. Get the idea? Yeah, you will get the last structure essentially. ये रिएक्शन तो सिंपल है ना. HBr में सिर्फ OH को replaced with the bromine. That's fine. This was the interesting part. Okay, so if they had said when reacted with one equivalent HBr, that would have been a better question. फिर लोग करते गलती. ठीक है. So ultimately answer will be option number 4. दोस्तों, लाइट चली गई है. I don't know how long my power backup will work. If the class stops, I will restore it. Don't worry. Okay. This power backup, I am not sure how long it will work. Okay. Let's just wait for the main power to get restored. It generally takes about 7-8 seconds for the main power. It's back. The society has the main power backup, but it takes like 5, 6, 7 seconds for it to come back. So in the meanwhile, if the Wi-Fi and the screen stops, then you know what's going to happen. Yeah. So anyway, this was a nice question. Let's move on to this was a homework question, people. Yeah. This was your homework question. We'll come to this later. This is the homework from the previous class. Basically, you needed to remember the formulas of temperature critical, volume critical, and pressure critical. If you remember these formulae, you will get the correct answer. Since we are in the flow of alkyl halides, just do that. We'll come to this later, okay? I'll come to this very soon. So Hall of Fame will be announced towards the end of the class. If you want to stay for that, make sure you remind me about it towards the end of the class. ठीक है? चलो, next question. Consider the following reactions. Okay, so we've got a very interesting question that had come in this year's JEE. Okay, I'll reduce the brightness of the screen so that you can see these properly. थोड़ा सा brightness कम करूँगा तो शायद the text will be a little clear. Yeah, consider these particular reactions. Which of these reactions will not produce the Setsef product? Okay, so what's going on is the main substrates are given. I'll write the reagents once again because they might be a little small for you to read. So the first one is concentrated H2SO4. The second one is alcoholic KOH, which is a classical case of elimination E2 reaction mechanism. Yeah, this is your tert butyl OK. Yeah, tert butyl O negative, the bigger bulky base that we saw a couple of questions back. Yeah, and this one is just heat. Okay, this one is just heat. It's elimination under heat. Fine. So now the next step would be to draw the structures of these substrates. They are given in a very cryptic form. If we draw the bond line formulas, it will make the question a little easier. Yeah, so let's make the first one. So you've got CH3 whole thrice on a carbon which has another carbon which has the OH group and a CH3. This is what it is. Please verify the structures. If there's anything wrong, please correct me. Okay, so 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Okay, fine. This substrate is CH3 whole twice, CH, इस पे लगा है Br, and then there is a CH3 on the side. Fine. This is your CH2, CH2, CH, same substrate in these two cases, and the last one is a little different. CH3, CH2, COH, CH2, something like this. Yeah, this is what is given to us. Now we need to do the elimination. पहला वाला है concentrated H2SO4. What will happen over there, people? Just tell me the reaction mechanism. Okay. In the first case, what is the reaction mechanism that is happening? In the first case, what is the reaction mechanism that is happening? Rohit, CH3 thrice है दोस्त वो. 1, 2, 3, 4, 5, 6. Okay. People, can you tell me what is the reaction mechanism for the first case? I know I get your responses in like 10-15 seconds, but that's fine. I'm gonna wait for that. Dehydration is okay, but reaction mechanism, people, that's the name of the reaction. What's the reaction mechanism behind it? E1, E2, E1CB, what? Samreen, it's not a substitution, so we won't call it an SN1. NEET is asking, NEET is saying carbocation mechanism. Okay, but what is it called? Siddharth is saying it is E1. Good job, Siddharth. People, elimination via a carbocation is called E1 reaction mechanism. This is a typical reaction of dehydration of alcohols. Yeah. So first thing that will happen is oxygen will capture the proton. It will leave, causing a carbocation to get created over here. Then rearrangement will happen. Yeah. Carbocation rearrangement will happen, then you will do the elimination. Okay? So this will give you an E1 reaction mechanism, and if you are smart enough to guess or deduce, this is going to be the final product. Yeah, that's the final product. There is a methyl shift that is happening from here to here. If you don't know what is a methyl shift, I'll explain it to you towards the end of the class, but revise carbocations, please. So if you are feeling confused with these reaction mechanisms, before I move forward, let me take a 10-minute break over here. Not 10 minute, 10-second break over here. If you are confused with these reactions, just a 10-second break, I want to tell you, in case you want to know what these reactions are, what are their dynamics, what are they doing, you know, basics of organic reaction mechanisms, then we have a very good playlist for you guys on our channel. Okay? It's a very simple series that you can watch. All right, तो मैं आपको दिखा देता हूँ where it is. Can you see my Chrome window? Yeah. So you go to the playlist section, okay, and just scroll down. यहाँ पे कहीं तो होगा basics of organic reaction mechanisms, ये वाला. Okay, organic reaction mechanisms. Can you see that playlist? Yeah, this one. Just watch this. So we have classes on SN1, SN2, E1, E2, E1CB, and we've got basics of reaction mechanisms as well in this series. Please watch this. Otherwise, if you still think life is not good, all you need to do is just go to the description box of today's video. Okay. Over here, we have the links for crash courses. What are crash courses? These are courses where our amazing faculty on our amazing patented platform will teach you for the remaining days before your examination. Okay, what you need to do in the last few days before your examination, if you don't know, if you need good guidance, this is the course that you need to join. Fine, very good course. We'll give you lots of tests, lots of questions to solve, etc., etc. Anyway, now let's come back to the question. So that is your E1 reaction mechanism. What about the second case? Yeah, what about the second case? फटाफट से दूसरे का reaction mechanism बताओ. I'll make the product over here. This is the product. Okay. What is the reaction mechanism over here? Alcoholic KOH, typical reagent for an E2 reaction mechanism. There's not going to be any carbocation over here. Okay, it's going to be a very quick reaction. KOH is a very strong base. Alcoholic environment does not really support the presence of a carbocation. Carbocations are supported best in aqueous environments. Okay, very rarely do we see carbocations in environments other than aqueous. So this is an E2 reaction mechanism. Okay, Vishal is asking, sir, how to decide E1, E2? Please watch that series which I have told you. Okay, it is a very long procedure. Okay, काफी दिमाग लगता है. That's why I would suggest you to go there and watch that. Carbocations are favored by aqueous environments. That is the main deciding criteria. H2SO4 will be in aqueous medium. So carbocation reaction mechanism E1. Alcoholic KOH is in alcoholic medium, does not support a carbocation very well, so it will be an E2 reaction mechanism. Something that comes by practice as well. Fine. Third reaction is very interesting. What about the third case? What is the reaction mechanism that's happening over here? Chalo, just to make it a little more simple for you, I'll give you the answer as well. This is what is happening over here. Answer to this question is option number C. Okay, ये answer है इस question का. This is the correct answer. This is the place where Hoffman product is getting formed. I'll write it as well. This is the case which gives you the Hoffman product. It's not the Sedzev product. Sedzev product is the more substituted alkene. But what's the reaction mechanism over here? Can you quickly tell me? With this, I'll throw a little bit of a googly at you, but if you understand, that'll be really nice. Yeah, just quickly tell me in the chat box. Just give me one more. Okay. So people are saying, sir, it should be the E1CB reaction mechanism. Interesting. My dear friends, last वाला तो simple है ना? This is just very simple elimination reaction. ये product बन जाएगा यहाँ पे. Yeah, just to give you a conjugated alkene. Yeah, this is also a Sedzev product. Sedzev product basically will give you the more stable alkene. This is a Sedzev product. No need to worry about it. Okay. ये वाले में what's going on? What's the reaction mechanism? Let me try to tell you that. उसका एक आइडिया देता हूं मैं आपको. Okay. Let this go away. I'll draw the substrate once again. ठीक है, ये था. Now what we are doing is we are essentially adding it to third butyl O negative, and a lot of you are saying that this reaction mechanism will be E1CB. Well, not really. Okay, the elimination reactions can be thought of as an entire spectrum. Listen to me very carefully. Okay, listen to me very carefully. I'll explain the idea to you, but listen to me very carefully. On one end of the spectrum, we have the E1 reaction mechanism. What happens in the E1 reaction mechanism? Let's say this is the substrate. First thing that will happen is you will get a carbocation. Yeah. First thing is leaving group leaves. Then we get the carbocation. Then the carbocation, if it has to rearrange, it rearranges. Then we get the major product, which is more substituted. So first step is loss of leaving group. Second step is loss of proton. Okay. So first leaving group, then proton. Fine. Now on the other end of this spectrum, the entire opposite elimination reaction is E1Cb. Let's say this is the substrate. Just let's take this as an example. Yeah. What will happen over here is, क्या होगा यहाँ पे? First thing that happens is the loss of this particular hydrogen. Loss of the acidic hydrogen happens first. Is this the most acidic hydrogen? No. Acidic hydrogens are the least substituted, so this one is most likely to leave. Okay, out of these two hydrogens, this is most acidic because if you remove it, you will create a carbon ion. If you create a carbon ion, it has to be at a place which is less hindered. More inductive effect is bad for a carbon ion. Okay, over here, very nice, simple carbon ion. Over here, if you make a carbon ion, there is substitution on the carbon ion. You don't want that. So you start with this particular substrate. First thing that you do is you eliminate one of the protons. Yeah. The next thing that happens is the leaving group leaves. Yeah. So यहाँ पे क्या हुआ? First thing that happens is the proton removal. Second thing happens is leaving group leaves. My dear friends, this is one type of elimination, one end of the elimination reactions. This is the other end of elimination reactions. Every elimination that happens in nature is somewhere in the middle. Every elimination that happens in nature is somewhere in the middle. Okay. Right at the center lies your E2 reaction mechanism. In the E2 reaction mechanism, your leaving group and the proton leave at the same time. मैं लिख सकता हूं यहां पे same time, simultaneously. Yeah. Go a little bit towards E1Cb. If you go towards E1Cb, what is happening is proton is leaving, leaving group is also leaving, but proton leaves a little faster than the leaving group. Okay, both are leaving at the same time, but the speed of proton leaving is a little faster than the leaving group. Okay, so this is the leaving group, this is the proton. Imagine something like this. Proton leaves faster than the leaving group. Understood? The reaction mechanism over here is E2 that resembles E1Cb. It is not the exact E1Cb reaction mechanism. It is an E2 reaction mechanism. These two are leaving at the same time, but the leaving of proton is faster than the leaving of the leaving group. Too many leavings in the same sentence, but yeah, I hope you understand what I'm trying to say. Yeah. Proton थोड़ा जल्दी निकल जाएगा, leaving group थोड़ा late निकलेगा. So the intermediate that gets formed in this reaction will look similar to this guy. Okay, the transition state, sorry, not intermediate. The transition state of E2 reaction will look similar to this. Therefore, you will get a product which is less hindered. Okay, E2 that resembles the E1Cb reaction. More often than not, you have E2 that resembles the E1 reaction. And in some cases, you have a pure E1 reaction because of carbocation rearrangement as well. Nice, right? Anmol is saying, are these questions from NTR Vyas? These are JEE Mains 2020 questions. Please do previous years. Okay, very nice questions are there. Got it? So because you have bulky base, it wants to capture the proton. For the bulky base, it is easier to capture the outside proton. Yeah. Why would it want to capture this hindered proton? It wants to capture the easiest proton out there. So bulky base captures this. Bromine also leaves at the same time. The transition state resembles the transition state resembles the E1Cb reaction. Okay? So it's like a spectrum. E2 is right at the middle of the spectrum. No elimination is perfect. just a point that I wanted to tell you. So this is the main product. You can check out the rest. Pretty simple. ठीक है जी. Nice. कोई तो एक स्ट्रक्चर मैंने गलत बनाया क्या यहाँ पे? हाँ, कोई स्ट्रक्चर मैंने शायद गलत बनाया ना इधर. लास्ट वाले का स्ट्रक्चर आई थिंक आई मेड इनकरेक्टली. Yeah, this is the structure in the last case. So there is only one elimination possible, and that would be I had made the structure incorrectly previously. This is the only elimination that can happen. It's a Sadzev elimination. Very simple. No problem over here. Cool. Chalo. Rohan, we'll do that when we have inorganic chemistry classes. Don't worry. SNI, Achyut, SNI reaction is बड़ा कॉम्प्लिकेटेड सा नाम होता है उसका. ओके, nucleophilic substitution with intramolecular return, that's what it's called technically. And what happens in the SNI is that you have a retention of configuration. Now there is a separate class that I've taken on SNI. You can just search for it, SNI Pahul sir, you can check that out. Okay, it's somewhere in alkyl halides chapter or somewhere. Okay, don't worry, it's just retention of configuration. You can check for it online. SNI reaction mechanism, it's a complicated reaction mechanism if you want to remember. Otherwise just keep it in your mind that SNI retains the configuration of the stereo center. Good question. Now let's do this one. This is also nice. ये question भी अच्छा है. So what's happening over here is you have the first aldehyde which looks something like this. Okay, so this is what you have. First of all, this is reacting in the presence of NaBH4 in the first step, and then it is reacting with SOCl2 in the second step. ठीक है जी. तो पहले तो ये कर लेते हैं. Let's figure out what is the reaction A. What is the product A? Let's figure that out. So first you are reacting it with NaBH4. NaBH4 is a very weak hydride ion donor. NaBH4 does not react with olefinic double bonds. It will react only with the double bond of the carbonyl carbon. So your hydride ion essentially will come and attack this position. The first product that you will get over here after the attack with NaBH4 is going to be something like this. Yeah, you're going to get an alcohol. NaBH4 is a reagent used to convert aldehydes or ketones into alcohols. That is one of the reactions of NaBH4. Now when you react it with SOCl2, this will give you a substitution in the place of OH. This is going to be a very typical SN2 reaction. Classic SN2 reaction. You're going to get this particular product. So this is your product number A. ठीक है जी. Done. Now we are reacting it with benzene in the presence of anhydrous AlCl3. We all know that reaction. Let's just take this guy. इसको ऊपर बना लेता हूं मैं यहाँ पे. Plus you've got your benzene ring, and this is happening in the presence of AlCl3. What will AlCl3 do, people? What's the role of AlCl3? What's the name that we give to AlCl3? What kind of a reagent is it? Siddharth is saying, sir, SOCl2 is SNI. Yes. Siddharth, sorry, my bad. That reaction with SOCl2 is going to be an SNI reaction. If you add pyridine, then it will become an SN2 reaction. Okay, so only SOCl2 will give you SNI reaction. Achyut, you were asking about it and it came. Okay, so people, this reaction over here is going to be your SNI. But we don't need to worry about the stereochemistry over here, so it's fine. Okay, we don't need to worry about the stereochemistry. This is not a chiral carbon, so forget about it. Otherwise, yeah, I said SN2, but it is an SNI reaction mechanism. Very good job, people. So lots of people are saying it is Lewis acid. Absolutely correct. Anyone and everyone who wants to learn the theory behind everything, we've taken long-term classes on this channel. Just go check out the playlists. You will find something that suits you. Fine. So this is a Lewis acid, and what it will do is it will essentially react with the chlorine. Okay? It will accept the electrons of the chlorine, which will render this into something like a carbocation, which is the electrophile that's going to react with benzene under electrophilic aromatic substitution reaction. Okay? So this electrophile will simply react with benzene under electrophilic aromatic substitution. The product that you will get after that is going to be this guy associated with 1, 2, 3 more carbons, and outside you've got a double bond. Fine. ये बन जाएगा. Very simple. So this is a Lewis acid. It generates a carbocation over here. This guy reacts with the benzene ring, gives you the product of electrophilic aromatic substitution. Want to give it a fancy name? This is your Friedel-Crafts alkylation. Yeah, typical Friedel-Crafts alkylation reaction. Alright, I'm throwing these reaction names at you so that you can revise them if you want to. If I give you a name of a reaction and you don't remember it, please go and revise it. You can simply do it from Google. Cool. अब क्या करना है? We had to add DBr. Now this is where the question takes an interesting twist. So the last question is essentially, you take this substrate and you add it with DBr. Instead of putting HBr, now you're putting DBr. D is what? Deuterium. Instead of hydrobromic acid, you have deuterobromic acid. Fancy. Now what's going on? Now what is the reaction mechanism over here? Do you guys remember the reaction mechanism of addition onto a double bond? Addition of HBr onto a double bond. Anyone remembers the reaction mechanism? किसी को याद है? अब मजा आ रहा है. Okay. So what essentially happens is that this particular double bond, let me take the red pen. This double bond, okay, this pi bond gets polarized in a certain direction. Okay, this pi bond will get polarized in a certain direction. Now since this carbon is an sp3 carbon, okay, it's going to give a slight inductive effect towards this side. Okay, look at the direction I'm pointing in. It's going to give a slight inductive effect in that direction. If you want to polarize this particular double bond, you would want to put the negative charge on the less hindered side. So this is how it polarizes. This is how you are supposed to imagine it polarizing. Then this carbon attacks the proton, which is a deuterium in this case. Okay, instead of having a proton, you have a deuteron over here. I don't know if that's the right name, but deuterium pe attack hoga. Okay, fine, cool. So what you will get after this step? What you will get after this step, I'll draw at the bottom. This is what you're going to get after this step. You're going to get this guy, 3 carbon bana diya. This guy is going to be associated with the deuterium. Let's draw that new bond with a black color. Okay? And do you notice there's going to be a carbocation over here? Now, this carbocation, okay, addition of HBr onto a double bond goes via carbocation reaction mechanism. Okay, now this carbocation, will it rearrange? अब बताओ, will it rearrange? Achyut, see, NGP is never explicitly asked. It's very obvious when you have done multiple questions. Like, I don't even think of neighboring group participation anymore when I'm doing questions. It becomes a little obvious. Just practice more and more questions. If you want to give it a label of NGP, then yeah. ठीक है जी, यहाँ rearrangement हो जाएगा. Yes. This carbocation will rearrange so that it can go here, so that it can become a benzyl carbocation, stabilize. Okay, so I'm gonna erase this jazz. I'm gonna erase this. Okay. People who have joined the class late, number 1, please watch the class from the beginning. Number 2, if you joined from the middle of this question, please rewind and watch the question from the beginning. And number 3, if you don't know the reaction of alkyl halides, please revise the theory first. There are theory revision classes on our channel. Just search for alkyl halides in one shot, Pahul sir. There's a theory revision class for that. Cool. So yes, it will rearrange. Okay, and after rearrangement, what will happen? 1, 2 hydride shift. Hydride shift is going to happen. This is the hydride that's going to move towards that side. Fine, pretty obvious, I believe. यहाँ पे आ गया positive charge, 1, 2, 3 carbons, and the last carbon associated with deuterium. Now this is the carbocation that's going to react with the Br negative. What is the product now? Option number 3 is the correct answer. A lot of people will choose option number 1. Bhool jao. Okay. Good question. Ragashri, can you see it's option number 3? Deuterium is on the outermost carbon, bromine is on the innermost carbon. 5. Fine. I read the numerical 5 in the chat box and said 5 instead of fine. Anyway, let's move on to the next question now. यार ये फटाफट से बताओ, this is a घटिया question. The decreasing order of reactivity of the following compounds towards nucleophilic substitution is, people, very obvious. Yeah, if this is the leaving group, this is the carbon where nucleophilic substitution is going to happen. Yeah, a nucleophile is going to approach this particular carbon. Now, if this carbon has a positive character, then the nucleophilic substitution will be good. So you need to notice where the carbon undergoing the reaction has more positive character. Over here, which is the carbon that will undergo the reaction? Obviously, the carbon that I'm going to mark in blue color right now, ye wala carbon. Yeah, this is the carbon undergoing the reaction. The benzyl carbon. The benzyl substitution is happening over here. Now you have to figure out which of these cases has the most electron withdrawing effect on it. More electron withdrawing effect, more positive character on the carbon, higher is the rate for substitution. Ragisi, it's fine, man. Not a problem. So batao, what should be the answer? People, this case, is there a minus M effect? No. There is only 2 times minus I effect. Why? Because you should remember, whatever is on the meta position, okay, if this is the carbon that we are worried about, this is on the meta position to this carbon, meta position does not, the mesomeric effect of meta position does not interact. Okay, so all you can remember is meta, no meso. If you want more explanation on this, please remember general organic chemistry. Please revise general organic chemistry. If you don't know general organic chemistry, go to YouTube and search for Epic GOC. Or simply join our crash course. Links are in the description for that. Okay? So, when you have, for example, 2 groups that are meta to each other, can you see they are meta to each other? Okay, don't think this is ortho, this is para. Nahin. With respect to this group, this is meta. Their mesomeric effects will not interact. You can draw the resonating structures to verify that. So when 2 things are on meta position, their mesomeric effects, their resonance does not interact. Okay. So since the nitro over here is meso to the main carbon in question, you won't have any mesomeric effect. You will have only inductive effect. Over here, you have 1 mesomeric effect, 1 inductive effect. Over here, you have 1 mesomeric effect. I should write 2 inductive effects over here. Okay, 1 inductive effect. Let's say that the inductive effect of this guy is negligible. Inductive effect of this guy is working. Okay? Para position is showing the mesomeric effect. M stands for mesomeric, I stands for inductive. I hope you understand that. Over here you have two inductive effects because this guy also going to show the inductive effect. This guy is also going to show the inductive effect. Yeah. And the mesomeric effect is going to be shown by the ortho position. Over here you don't have any effects at all. So ultimately, my dear friends, what is going to happen? This guy has the most electron withdrawing effects, most reactivity towards SN2 reactions. Then you've got structure number 3, then you've got structure number 4, and finally you've got structure number 1. This is the decreasing order of reactivity for SN2 reactions. Okay, fine. Rohit, G was any group. Okay, any group. ठीक है जी, हो गया, फाइन. रमन इज सेइंग 2 में स्टेरिक इनहिबिशन ऑफ रेजोनेंस नहीं होगा क्या? It is possible, but quite unlikely over here. Okay. If that happens, then weird shit will happen over here, but you don't need to worry about it. Okay. Steric inhibition of resonance generally happens, when you've got NH3 and CS3, something like this. The thing with nitro groups is that it is planar. Okay, so planar groups don't generally have that much of steric hindrance. Okay, the nitro group is simply nitrogen, oxygen, which is planar, and then you've got CS3, which is tetrahedral. So these can orient themselves in a manner that steric hindrance is not that high. But when you've got tetrahedral and tetrahedral, sorry, NH2 आना चाहिए यहाँ पे. When you have tetrahedral and tetrahedral groups, then your steric interactions become a little more significant. Okay, so anyway, let's move on to the next question. Rajat, someone else also asked me this earlier. I will start it soon. The thing is, I'm in discussions with my team on how to make it a much better course. So the logistics are taking time. We are trying to do something interesting with that course, something new for the entire organization. So I'll let you know. Okay, I'll let you know. Ananda is saying, what happened to your water bottle? Arey yaar, I left my water bottle in my room. It is very far. I have this wired mic. My refrigerator is closer to me. So I just took this out of the fridge because I was feeling thirsty. Okay. Chalo. Siddharth, yeah, there is a dative bond in NO2. I just quickly drew that to show you that it's planar. Chalo. ये बताओ, simple question, but based out of theory. That's why it becomes a little more interesting. बताओ, the mechanism of SN1 reaction is given as well. Everyone knows the reaction mechanism of SN1, है ना? You have a carbocation reaction mechanism. A student writes general characteristics based on the given mechanism as. Number 1 is the reaction is favored by weak nucleophiles. Second is I think they want to write R positive would be easily formed if the substituents are bulky. Okay, this basically is carbocation. Okay, I think that is what it should be. I just copy pasted the question. I'm looking at it for the first time. The reaction is accompanied by racemization. The reaction is favored by non-polar solvents. Which of these observations are correct? Let's think about it. So our mechanism is SN1, which is a carbocation reaction mechanism. Carbocation reactions are favored by polar solvents, so this observation is definitely incorrect. Yeah, carbocations are favored by aqueous conditions, which is a very beautiful polar protic solvent. So polar solvents favor the SN1 reactions, non-polar do not favor the SN1 reactions. Let's forget about it. This reaction is accompanied by racemization. That is correct, isn't it? Yeah, you don't have pure retention of configuration, you don't have pure inversion of configuration. Since the carbocation that gets formed is planar, the attack of the nucleophile can happen from either side. That's why you undergo racemization. R product and S product both are formed. Okay? First one says the reaction is favored by weak nucleophiles. Oh, absolutely, that is correct. Why is it favored by weak nucleophile? See, if it is strong nucleophile, it will want to do the SN2 reaction. SN2 reaction is faster than SN1 reaction because that's a single step reaction, yeah. Now the thing is, if you have a strong nucleophile, it just wants to attack as fast as possible. So SN1 will be favored if the nucleophile itself is slow, so that the substrate has enough time, its leaving group leaves, then the nucleophile realizes, oh, I have to go and attack. So the first statement is absolutely correct. Now what about this guy? Carbocation would be easily formed if the substituents are bulky. This is a very general statement, okay? This is a very generic statement. Anmol, yes, polar protic mein hota hai, that's why the last option is incorrect. Fine. So the thing is, this is a very generic statement, and you know that more substituted carbocation is more stable, isn't it? We've all heard that. Why is it more stable? Because there's more hyperconjugation, there are more alpha hydrogens, etc., etc. But if I'm saying a very basic statement, that's going to be more substituted carbocation is more stable. It can also be said that carbocation will be easily formed if the substituents are bulky. Bulky bolo to more substituted. So if I'm talking in very general terms, है ना, बहुत ही general बात अगर मैं कर रहा हूँ, so statement B will also be correct. Okay. If I'm talking about a very general thing, then statement B will also be correct over here. Fine. So option 3 becomes the correct answer of this question. Chundari Ramamurthy is saying, do you have AC? No, I don't. Bangalore, you don't need air conditioners. The weather is pleasant 24/7. And I live on the 14th floor. There is lots of wind at this height anyway. Okay. तुषार नहीं, यहाँ पे बैंगलोर में the temperature is what 24-25 degrees Celsius होगा अभी. I'm not sure exactly what's the temperature, but it's more than 20 degrees Celsius, so it's not cold at all. Yeah, nice. Shanmukha is asking what's after the hybrid sprint. We will think about it after the hybrid sprint. Before JEE first attempt, we will do some mock test solving, full syllabus mock test or something like that. Maybe some challenging questions, let's say 10 questions from any chapter. Okay? Something like that. And after the JEE Mains first attempt is done, we will do something for NEET and something for JEE Advanced, because JEE Mains students can watch the hybrid sprint once again. Okay. Yeah, 14th floor. Technically the 13th floor, but they don't name this floor 13 because 13 is an unlucky number, so they call it the 14th floor. But yeah, काफी ऊंचा है. चलो, how many monochloro derivatives are possible when 3-methyl pentane is subjected to free radical chlorination? This is my favorite question. This is the googly question that I was talking about. If you can solve this correctly, if this was an offline class, okay, whoever solves this question correctly, I'll give them a chocolate. This is that chocolate question. If you know this, if you know how to solve this correctly, मेरी तरफ से गिफ्ट. हर्ष नहीं भाई, I've actually never been to Delhi. I've been to Delhi, but only for like 2-3 hours. Anmol is saying isomers are to be included. Yes, Anmol, they have to be included. Ankit, I would love for that to happen. And if this was not the COVID time, then I would definitely have kept some meetups at 1 lakh subscribers. Okay, I would go to major cities on my motorcycle and meet up with students. That is what I wanted to do. But COVID, maybe later this year when everyone is vaccinated and herd immunity is a real thing, then I might do that. अच्छा चलो 4-5 आंसर आ रहा. Lot of people will say 5 is the answer. Okay, some people will say 4 is the answer, but that is absolutely incorrect. Some people will say 5 is the answer, which is okay, good, but there is some observation that you are missing. Try करते हैं, ठीक है. How many monochloro derivatives are possible when 3-methyl pentane is subjected to free radical chlorination? Okay, 1, 2, 3, 4, 5. 3-methyl pentane. Is that the correct structure of 3-methyl pentane? Let's try to draw all the monochloride derivatives and then we'll see whether stereoisomers are possible or not. Okay? तो यहाँ पे पहले तो डाला क्लोरीन इधर, ठीक है? Then what we can do is we can put a chlorine over here. Then the next thing that we can do is we can put the chlorine over here. Yeah, there was a hydrogen that you could have replaced to put the chlorine, so that's fine. And then just a second, okay? So if I'm talking just about, yeah, the क्या कहते हैं position isomers, then these are the possibilities. Okay, if I'm talking just about the position isomers, then these are the possibilities. But now we have to identify chiral centers. Okay, now we have to identify chiral centers. Let me see if anyone has given the correct answer. Amir Hussain, I think your answer is correct. Aman, interesting. Aman and Amir, I think you guys are giving the correct answers. Let's see. सोच के देखते हैं. So in one of these cases, I can see that you guys will notice that there's a chiral center. Let's take the blue pen to mark out the chiral center. Is there a chiral center over here? Yeah, over here you've made a chiral center. Yes, isn't it? So now you will say, okay, 1, 2, 3, because this will give you 2 isomers. Yeah, so 1, 2, 3, 4, 5. And most people will say, okay, 5, baat khatam. Let me show you some more chiral centers, please. Did you see that coming? There's no chiral center here, there's no chiral center here. These two are very simple. Now think. Aaya maza? Now does it make sense? So people, this guy has only one chiral center. Depending on the orientation of this guy, yeah, depending on how chlorine comes and attacks this particular carbon, there are two possibilities. You could have either the R configuration or S configuration. So you have to count 2 isomers from this guy. This one over here, whoa, 2 chiral centers now. Yeah, so you could have RS, okay, then you could have RR, you could have SR, and you could have SS configurations. Yeah, RS, RR, SR, SS configurations. So essentially we are talking about 4 different isomers from this guy, है ना? यहाँ पे सिर्फ बनेगा या R बनेगा या S बनेगा. This guy just one case, this guy just one case. Yeah, 4, 5, 6, 7 and 8. My brain says 8 should be the answer. Some people are saying 9 should be the answer. How is it 9? Can you tell me? Some people are saying 9 is the answer. What? Did I miss something? Please tell me. मैंने क्या मिस किया भाई? Funny, how is it 9? Can you tell me? मुझे 8 दिख रहे हैं. But did I miss something? It's a genuine question, okay? I'm not making fun of anyone. एट ही है ना? हाँ ठीक है. Cool. So nice. I like this question. Lot of you will do this incorrectly in the first go. Okay. Aditya, please rewind it and watch it. And if you don't know what are chiral centers, what are stereoisomers, then please revise general organic chemistry by watching this very interesting series that I've taken on YouTube called Epic GOC. Just search for this on YouTube and you'll be able to see. Okay. चलो बढ़िया. I love this question. ठीक है, I think this one should be your homework. We are done for the day. So this is your homework question, people. All you need to do is answer it in the comment section down below. Tomorrow we have the class of mole concept questions. तब वो कर लेंगे. We'll say the names of the few people who gave the correct answer for this one. Please answer in the comment section down below. Just take a screenshot of this one. I had reduced the brightness. Let me increase the brightness. Yeah, now my face looks a little better. Okay. Just a second, okay. I have to talk to you about the homework question as well, which I gave you in the previous class. Just note this down. I am just fixing something. The questions for the day are done. If you want to leave, you can leave right now. I'm just trying to figure out something. Then we will chat with each other. Yeah. And if you're leaving, make sure you hit that thumbs up button and subscribe to the channel. If you're not leaving, then good. We'll talk to each other in a while. Just give me one moment, okay? You guys can chat with each other in the chat box until then. अपने आसपास आपस में गप्पे मारो, please. That's what happens in an offline class as well. Talk to each other if you want. Yeah. Okay, now for the Hall of Fame of the previous class. Just a second, okay? उसकी मैं class खोल देता हूँ so that we can check out how many of you have given the correct answer. चलो जी, let's come back. Cool, ये आपने screenshot ले लिया. So as I promised you, I'll take the Hall of Fame of the previous class at the end. ठीक है जी. So straightforward questions है, all right? These are the formulae that you have to use. Now, critical temperature, critical pressure, critical volume. If you want to learn a little bit more about the virial equation of state, then you can check out a class that I've taken on the virial equation. You can just write virial equation, Paul sir. There is a class that I've done on it. It's not important at all. In case such a question comes, you need to remember these particular formulae. Formula of critical temperature is 8A by 27 RB. Formula of critical pressure is A by 27 B square, and formula of critical volume is 3B. When you use that, you will get B, C, D as the correct answer. Straight away, formula application. That's why I gave this question to you, so that you can revise these formulae. And this is one of those rare cases where I tell you to remember the formula. Yeah, I know. Not a cool thing to do, but sometimes you have to. Chalo, so let's see how many of you gave the correct answer. Kanishk, good job. Geetansha, Murli, Chundri Ramamurthy, and Dushyant, and Kaushik, and Savan, and Aditya, and Ankit, and DM Kids, and Krupa, and everyone is giving the correct answer. Karthik, and Rishi, and Debargya, and Trishank, and Soham, you missed an option. Chandrasekhar, Akash, Saurabh, Abhi, you missed an option, I think. Rohit and Joyanti. Okay, very good. Almost everyone is giving the correct answer. Good job, people. चलो जी, now I'll just chat with you guys for 2-3 minutes and then we'll wrap up the class. ठीक है जी? Priyanka is saying we'll not be talking in slow mode and offline. That is true, Priyanka. But if I disable the slow mode, then there's going to be someone that's going to go. You know what happens, yeah? One person will just keep messaging one thing forever. तो उसका मजा नहीं आएगा. Yeah. So once again, reminding you that in case you guys want to join the crash course, links are in the description box down below. And everyone who's asking me to beatbox right now, I'll do that only in a casual session, not right now, okay? Vihan is saying, why are you not active on Insta? Because just like that, man, there's no reason. Okay? There's no reason. See, one thing that motivates me to do stuff in life is whatever I'm doing, is it different from the others? Okay, that's how my brain works. If I'm doing something that is different from what everyone else is doing, I'm happy. 3-4 years back, or maybe 5-6 years back, social media was not that popular. Okay, there were people who were active on social media, but not everyone. These days, everyone is active on every type of social media. Everyone has a YouTube channel. Everyone has an Insta profile. Everyone wants to become an influencer. So now I don't want to do Insta because everyone is doing it. Weird reason, yeah, I know. So इसीलिए my Instagram, every day there are some new followers on it, but still only the same 34-35 posts. Okay. Someone is saying you're looking smart in this t-shirt rather than the Vedantu one. I know, Vedantu t-shirt, when you wear it every day, of course, it doesn't look that good. But the thing is, I'm wearing a sky blue turban, and with the sky blue turban, that t-shirt doesn't really go properly. So, Afshan Ahmed is asking, "Aapka birthday kab aata hai?" 1st of April. And I'm not kidding, it's actually on the 1st of April, okay? Sai Charan is saying, how to complete organic in these 20 days from basic, please answer. See, if you want to complete organic in 20 days from basics, it's not possible. You can't complete it. What you can do is try to become an expert at general organic chemistry, and whatever knowledge you have of organic, if you do, try to solve more and more questions from that. Otherwise, just read as much NCERT as you can. That's the only thing that you can do in the last 20 days. So for general organic chemistry, you can search for this web series called Epic GOC. It's there on YouTube. I've taken it. That will take care of the very basics of organic chemistry. Above that, read the NCERT, solve questions as much as you can in the remaining days. If you want to do it entirely, it's not possible. So let's not, give me, I will not give you false hopes. Okay. Funny, thank you so much. Ragesh is saying, why do you like chemistry? I don't know, it just works for me. I really don't know why my brain understands chemistry better than other science subjects. Tushar, my cats are locked in the other room. So the thing with my cats is, wherever I am, they would want to come there and play around me. Okay, I don't know why. ये उनका आदत है. If I'm working in the kitchen, they'll come on the kitchen shelf and start, roaming around. If I'm taking a class, now right now you don't see the entire setup, but there's a camera over there, the screen, there's 2000 wires, not literally, but there are lots of wires. I have 2 laptops set up over here. One is for streaming, one is for reading the comments, and tons of wires. Okay, so when my cats see these wires hanging around, they will disrupt the entire setup. So that's why I locked them in a room before taking a class. तो अभी मैं खोल नहीं रहा उनको. Okay. I have been to Kolkata once, Kaushik. I don't watch animes. Rhyme John. I hope I'm pronouncing your name correctly. Anyway, people, it's almost 10 p.m. so I'll take your leave. Thank you so much for joining in. If you enjoyed this class, please make sure you hit that thumbs up button. Stay subscribed. Tomorrow, the class of Mole Concept is going to be there at 8:30 p.m. Hybrid Sprint once again. I am expecting more people to turn up tomorrow because somehow Mole Concept is a very popular chapter. Yeah. So I'm going to see you tomorrow. Until next time, thank you so much. If you want to join the crash course, links are in the description box. Anything more, you can leave a comment later. Good night.